I'm happy to have you here, and it is for me very interesting to have someone like you here who is, who did the transition from academia to the industry. But maybe I give you the opportunity to introduce yourself, and then let's dive right into the story.
Yeah, thank you. So I decided to spend my working life on creating helpful assisting robots that should make life easier for humans. And as I think for many others in different technical fields, it has to do with how you were grown up to start with. I hear that both in podcasts and other situations, that your childhood actually decides quite a lot of what you decide to go for in life.
Yes, absolutely.
So, yeah. So I will tell you a little bit about my background, and then an important part of my life was all the years I spent within and together with ABB Robotics. And then there is a time after ABB Robotics and in academia. And then finally, in the end, I realized that the only thing to make really good robots a reality is to create a robot company yourself.
Awesome.
So it took me over 30 years to realize that. But it all started actually with that I'm grown up with farming, small farm, well, medium-sized farm, I should say, with both forestry and farmland in southern Sweden. It's like 1 hour north of the south coast of Sweden. And it was always hard work when all the classmates in school and the summer they went to the beach or the lakes. Me and my brother, we had to work at home. Same in winter because we had the forest and we had to do forestry work. All the friends, they were doing just fun things, playing games or whatever. So always working, and also my relatives and family, etc. We were known to be hardworking people. So to do a lot of work was the natural state.
I'm sorry, do you mind me if I ask what period of time are we talking about? When is this?
Right. So I'm very old because I am born 58. So I'm 66 years old. I don't feel like that, but that's another story. Yeah. So we are then talking about the 60s when I grew up and beginning of 70s. So I was from beginning interested in mathematics and reading. So my brother was is 1 year younger. He was from beginning stronger and did just hard work, just did it. And I was always thinking, can't this be done in some other way? And we had a very good mechanical workshop at home. And my father, he built his own machines to some extent. He built his own forestry machine because there was no machine on the market that was good enough. So that's one thing, that you can build your own machines to create things that are better than you can buy. That plus that hard work made me think, okay, how can I then build a machine that relieves me from this tedious work? So that is my 1960s, and then in the 70s.
So sorry. So this is the motto of work smart, not hard, right?
Yes, yeah. So I learned to compute and read by myself before starting school. We had no neighbor farms with other kids, so it was only me and my brother. So I was just simply interested in numbers and those type of things. So some of my relatives throw some math issues to me, and I was always fascinated by mathematics. So then in the 1970s, I just took the, yes, as we call it, gymnasium, and then continued to university, like technical university. And I went into mechanical engineering because if you think about machines that should do some helpful work for you, obviously you have to have some hands and arms and motors and mechanical things. Without mechanics, nothing gets done. Well, today you have robots that just crawl internet and process information. But if you think about physical work, you have to have mechanics. So that's what I studied. But I realized after a couple of years at university that, oops, electrical, there are many, many things. I didn't decide for electrical engineering because I'm colorblind. So I thought these small colored rings on the resistors, I will never be able to figure those out. So one reason I studied mechanical engineering. So but then I took all possible courses also on electrical engineering. So last 2 years I studied both actually. So I took all the control and math and programming, everything. I simply read everything. Beginning of university, it was more party. As before university and also during my military service, the 1970s was a great decade because there were no problems in life or in world. No bad diseases, just fun. But at the end, I decided to really learn and study. And then at the end of the university, the industrial robots were introduced in our production engineering course. And then it was ASEA. Later, it became ABB. The A in ABB is ASEA, which is an abbreviation for the Common Swedish Electric Company, which was then 100 years old already. So naturally, I did my master thesis at ASEA or ABB. So that was 82, summer 82.
Just 1 second regarding the how you really got into numbers. You said that you have been interested in numbers very early on, but you said that you were able to enjoy your 70s as well, right? But I hear this very often that people, when they got interested in something, even though they had not been, let's say, this is not the case in this is not in your case, but I heard this very often that people said, yeah, the very first few years I was enjoying life very much, but then I got hooked, I got interested in, so I went back to the basics. I became very good at math because I needed to in order to do the things I wanted to do, right? I mean, this might not have been the case in you because you said you have been interested in in math very early on. But I see this very often. You do need to understand you do need to have a good foundation because these are the tools that enable you to do the things you would like to do actually, right? So if you're not staying in math.
Yeah, right. And I could have been a better theoretician if I studied harder in the beginning. But yeah, I'm still happy about what I learned. And
Nice.
So I did my master thesis at ASEA, or let's call it ABB, because after just a couple of years at ASEA, it was merged with the Brown Boveri in Switzerland, and then we had ABB. And I worked there 6 years first. I was in charge of the motion part of the very first fully digital control system, where we did down to the motor control with the torque and current controls of the motor phases and everything up, including introducing dynamic models and gain scheduling and these type of things. So that was a great experience. And before then, the first years at ABB, it was still analog electronics for the servo drives. And how do you do gain scheduling then? I mean, how do you change the gain with respect to the inertias of the robot arm? Well, you don't normally. But we introduced the first gain scheduling for the first ABB, or I say a spot welding robot, the IRB 90. For axis 1, and that was an analog multiplier put on the feedback of the velocity, because that effectively changed both the position and velocity gain in a almost optimal way. So, and also the like PID parameters, those were resistors and capacitors. So if I went out to a customer that needed some special tuning, it was soldering and changing hardware components. Of course, nowadays everything is in software, but it was a very, very good period at ABB those years when we went from a rather small division of ABB. I mean, in the beginning, there was no expectation that we should earn money on robots. We were there for the high-tech profile. But that, of course, also changed. So it was wonderful years up in Västerås. It's outside Stockholm, 1 hour west. Wonderful years in all ways. So learned a lot of things.
And you were talking about the transition, being very analog and now doing things that we're unable to do before. So we're talking about a real game changer here. And you said here there was no expectation, which is nice because then you are more free to do and to explore. And but looking back at it, so this was an environment where it's a playground, right? You do have an idea, you do test out things, but really making this transition, coming up with things that nobody achieved or tried before. What did that to your team? I mean, how big was the team, and who was in the team? So how did you guys manage to come up with those and going in this direction?
Okay, we were about 9, 10 control engineers. I was on the motion control part, and then there were about the same amount of people on the software for interpreting robot statements and generating trajectories and things like that. Sorry, what was your question? You said.
No, I said that. So you are now in an environment where you're testing out new things, right?
Yeah, right.
And
okay.
How is that with management and within the team?
Yeah. So even though we had quite some freedom to try out and work on different solutions, the requirements industrially were still very, very demanding. I mean, we had the big, for instance, German companies buying and putting requirements. And so we really worked towards the industrial needs. But we were allowed to do it in a way that did not give immediate profits for ABB, because it was just judged that, well, this is some future promising product. Sooner or later, we will earn money on it, so don't worry, just solve the problems. And that was very, very good to work in a company like that.
This is how you do innovation. So this is the reason why a lot of companies today, especially in Germany, fail with innovation, because they said, we need to make money on those very early on. If we don't make money on this, we will not put any money into it because we are burn money, so to speak, versus understanding you need to burn money in order to do the things you haven't been able to do before, right? So I really like this being very mechanical and then trying to do the bridge into the digital work or the software world, right? And allowing this only by really giving you the playground and the tools and the freedomness to do this. I think this is something, very unique, especially nowadays.
Yeah. Then when we had the first fully digital product out, I realized that to really do good motion control, I needed more theory. So then I applied for the PhD position down at Lund University. It was also coinciding with that. Then I had 2 small kids. And with small kids, it's handy to be close to parents and relatives. So I'm coming from down here, South Sweden, Lund, and Lund University then. So I got this PhD position at the control department. My supervisor, Carl-Johan Åström, is quite famous in the control area. And I also, during the years there, had the other 2 supervisors, Klas Nilsson and Rolf Johansson. So these 3 persons learned or taught me quite a lot of things, both theory, but also many other things in terms of how to deal with and think around high tech and relations to other areas. And by the way, Lund University Lund is also very, very good in the way that it's really free thinking. I mean, there is no rules in this city, and you can see on how many innovations that have come from here, ranging from the inkjet printer to Bluetooth and other things, dialysis machines, etc. So it's a good atmosphere here in Lund. But then it was 92, 93. My closest supervisor, Klas Nilsson, he got a professorship up in Linköping. And there was a stage in the mid-90s where robotics was at risk at the university because there was no real funding, no full professors in the topic. So I took a few extra years on my PhD studies to arrange for external financing and got some equipment from ABB in clever ways, renting first, and after deduction, before the last deduction year, could buy off it for a lower cost that passed the ABB audits, etc., etc. So I managed to establish, together with colleagues, of course, because it's all teamworks. So we got robotics research established first at the control department. So then, but at this time I was all the time employed by ABB. So I was on leave for PhD studies, and I went to ABB a few times a year. Sometimes I did some programming on some low-level algorithm. So that was good. But the plan was to return to product development at ABB all the time. And at that time, ABB also had a department here in Lund at the Science Park, where we are now at Cognibotics, actually. But then when I was done, and there was some reorganizations and no one could take the decision for me to work down here, let's see here, 96, 97, I was commuting to Västerås outside Stockholm. But with the plan to then establish a group down here. But then there was all reorganizations and no one could take decisions. So in 97, I quit ABB and got a position at computer science, as a stand-in researcher. And I should then also, then I became a computer scientist. And the reason I started at computer science was actually the need for robot languages.
So again, the need was driving the innovation and the change of you from a mechanical engineer to become a data scientist.
Yes. I did, during my PhD studies, work more and more together with computer science because they have a very good compiler group. And it was so obvious that no matter how good algorithms I put in the motion control, if it can't be configured automatically and motions programmed efficiently, there is no use for the motion control algorithm. So the need for robot languages was getting clearer and clearer. And when I quit ABB and they asked me to come and work first temporary at computer science, I said, yep, that's perfect. So then one thing after another, I started to build up with actually lots of European projects. And if I look at what we have now at Cognibotics, I would say it's mainly results from European projects that we have been working on or building on. So I often emphasize that I'm European. We Europeans have a tendency of saying, well, I'm from Germany, I'm Italy, or French. It's no, I'm European.
I love the idea. So I'm totally with you.
And also from time to time, things there are political, like research political things that make it such that all the research funding goes to places near or inside Stockholm. So there was also that reason that started to working, for instance, with Fraunhofer IPA in Stuttgart and Martin Hägele, and then I got in touch with different robot companies and integrators, and we were running several projects together with Fraunhofer. So those were the years then beginning of the millennium. But all this time it was together with ABB, although I was not employed there. We had these research projects, and ABB was really on a good path to have all types of products and yeah, including things related to the machines we have created now at Cognibotics with the parallel kinematic machines. But then something happened in 2008. What happened? There came a financial crisis. And ABB mismanaged the financial crisis. After the financial crisis, Fanuc, who did the right things, they recovered quickly and got #1 in the world. ABB reduced engineering by 25%. Of course, all the good futuristic projects were closed or put on hold. But you know, these persons that were left and had to take care of all the work after the crisis, there were several years that, not quite the right things were done. So up to the financial crisis, I was working with ABB, and that's basically 24, 25 years I was working with ABB Robotics. I'm still good. I mean, we have been doing some work for them, and I know some of the managers, but now it's more like a normal business relation. And some of us at Cognibotics also has an ABB background. But ABB Robotics is a large part of my robotics background, so to say. And I always had big respect for what it takes to create a robot company, in particular if you have hardware also. So obviously one should work at an established company, because that's where you have all the hardware designers, supply chains, quality control, production facilities. But then in the end, I realized that I will never, even if I work inside ABB, if I would continue, I would probably not be able to create the robots that humanity needs. And I can look at that from a risk perspective. I mean, if you start your own company and put all your savings and mortgage your house and put everything in, as I did, that's of course one risk. But if you play it safe and you continue working at KUKA or Fanuc or ABB or any of these established company, there is another risk. It's that your ideas never became reality. And for me, that risk felt bigger.
Yeah.
Or maybe not bigger, but it was something I didn't want to, when I was really old, look back and say, oh, I never really tried to do what I was thinking.
The risk of failure can be lower than the risk of regret, right? So you're always paying a price, right? And now you need to make the decision: is it the price of failure, or is it the price of regret? And so you will get hand the build over anyway. So and now you just need to decide what kind of build is it. And I think you did right in the what could have been, right? especially as you said, how much control do I have? Can I, how much can I influence, right? I mean, if you are within the company, and I think the new Nike CEO is a good example in on social media at the moment because he worked his way up from a small intern all the way for I don't know 17 years up to the CEO, right? So there might be a very small possibility, but then you're still in the big company. How much can you really do within the big companies because you have middle management and top management, and so then you have the stakeholders, the shareholders. So I can understand your point, and respect for having the guts to do it. So then maybe you can tell us a little bit about how things came together and what are you working at the moment.
Yes. And I also want to add that around the millennia, 2090s, beginning of this millennia, I was asked to apply for some management positions within ABB, robotics or corporate research, so a few times. And I had discussions with them, and then I said, no, I will waste my time in meetings and PowerPoints, and the organization is too big for what needs to be done. So no, thank you for asking, but the answer must be no. So then I was then for some more years until 2012 thinking that let's do good research and give results to companies that can exploit them. But then among the projects we had, there was one project, Comet. It was actually the first EU project that was funded and completed based on the extra funding arranged due to recovering from the financial crisis. I was in Brussels together with the CTO of ABB Robotics when the decision of this policy change was made. So we were in the meeting, and then came this message in, and oh, sorry, we need to rearrange everything here, because we were invited to discuss upcoming robotics research frameworks. And then it all changed, so there were other priorities. Now it was recovery from the financial crisis. And one of the projects there, and that was also together with Fraunhofer IPA in Stuttgart, the Comet project, it was coordinated by Delcam, now part of Autodesk. And the odd thing in this project was that there was no robot producer. I always had a robot producer in my projects. But this was CAD/CAM machine builders and robot users, but not robot producers. And when I remember it was at the technical meeting outside Berlin, and I was sitting listening to their various suggestions how to improve offline programming, because these were CAD/CAM people. Of course, you want to go from your CAD drawing to a robot that does the machining. And many of the suggestions that came up were like, okay, I remember when we discussed that at ABB, and it didn't work because of that and that. And then it just came to me that, oh, let's see here. If I put the equations inside out and look at it all from the robot's point of view, and the robot can do motions that excite the loads of the joints and links such that it can, just by its internal sensors, determine its elasticity, its backlash friction, all these parameters that are needed to be known for model-based control. So up to that point, I always just gave away ideas to project partners. And then I tried to explain to the consortium my idea, how this could be solved, and no one understood me. Then I
because of the technical lack of technical expertise, or
yes. And then I was Googling and searching, and I couldn't find anything like it. And then I saw in the university internal newspaper that the university actually has a so-called innovation department, where you can go if you have an idea, and say, well, no one else understands me. Maybe these guys do. And they did. So they changed my mind from being a scientist to being an entrepreneur.
So now we are talking about your early 50s, right?
Then I was, let's see here, now we are 2012. So I'm over 50, yeah.
Because I hope you don't mind that I'm asking this, but very often, and I see myself in the same position. I'm too old to do this. I'm too young to do this. I'm too old to. And very early in the conversation, you said your age, but you said you don't feel like it, right? And
Right.
I'm doing this podcast mainly because I would like to be an inspiration, or not me, but my guests, for other people. So showing it doesn't matter if you're 18 and or 2022 and you see all those startups being founded by founders. This is what comes into the stories. But if you look at the data says that the majority of successful startup founders or company founders are in the mid 40s, right? So, and as you said, there was a need, and you changed from mechanical to computer science. The majority of innovation came because there was a need, so you were striving to solve the need. And here again, you saw there was a gap, so you're trying to solve the need. And this is what is necessary, not the age, right? I mean the
Right.
technical expertise, obviously,
Yeah.
but I really like that this is so your CV is a like example of the same pattern of seeing problems and trying to solve them.
Yes. And I would even say that if you are a researcher in academia, maybe very successful, when you get, let's say, a bit over 50 or maybe 55, and you have like 10, 15 years to retirement, I think everyone should think a little bit extra. What good does it do for the world if you publish a few more papers? And what good does it do for the world if you start to create a business? And if your conclusion then is that, well, it's not possible to create any business of this, one should then think, okay, is this really fundamental research that is just for curiosity? Or maybe I'm researching something that's not needed. Then I should change anyway. Well, of course, it's more complex because
No, but it's
scientific
true.
community is about creating knowledge. I acknowledge that. So not profit, it's knowledge creation.
But I mean, to really challenging the things that we do, I'm doing it on a business level, right? Because I'm not in academia, and really challenging the things I'm doing on a daily basis, weekly, monthly basis. Is this contributing to anything, to the bigger
Mm.
goal, right? Whatever that might be. So, good
Yeah.
question.
But if I now look at what we have at Cognibotics, so 2012, when then we applied for the first patent together with the innovation department of the university. They arranged for some funding for that. And then 2013, we got the patent granted. By that time, we also had the second one written, filed. So then we started. So that's 11 years ago. But then I was very afraid of venture capital.
Mm.
And also decision makers that didn't know robotics.
Mm.
So we tried our best, me and my 5 co-founders, to just build it from our own resources.
So bootstrapping yourselves.
Yeah. Yes. Yes. So that meant, for instance, that we took the software we had from our PhD studies and software packages from internet and combined it as quickly as possible to what we thought was the minimum viable product.
Nice.
And then fall 2015, we had the first customer tests at a robotic company in northern Italy.
Mm.
um, but what worked so nicely in simulation didn't work in practice. It turned out that the dynamics of the wrist motion in the upper arm of the robots were more complicated. And our optimization got stuck in local minima. So then winter around Christmas, New Year, 2015, 2016, we gathered all here. And by the way, at the customer site, I said, okay, I see here we have a problem. Let us review this and we will come back with the solution. And I said, okay, tell me when you're done. So, and then we were sitting here beginning of 2016 and said, okay, this was apparently much harder than we thought. So what do we do? Do we give up? But the decision was, no, actually, we took too many shortcuts. There is no shortcuts possible for high performance motions. And where performance is both accuracy, that's what we started on, just accuracy, below, for speed below the lowest resonance, but also for short cycle times when you have to work on a high frequency range of the mechanics. So we decided to rework everything from ground up, all tools, all algorithms, the formulas. We went for screw theory, for instance. We have, and that's also when we decided to take in some external capital. And I had an investor that I talked with from beginning, and I said, we try ourselves. And then when I needed capital, he said, okay. And then we have had at least 3 investment rounds when we gradually, step by step, got things working and increased our ambitions. And now we have 2 types of robot arms, hardware. One, the Sigma Tau PKM, has a patented wrist solution, because robot wrists, that's the weak part of a robot arm, because if you make the wrist very steady and stiff, it gets heavy. And if the wrist is heavy, the entire arm needs to be heavy and so forth. So robot wrists have always been an issue. So that's what we have a solution for machining and heavy duty applications, and also high precision. And then we have the intralogistic arm, the hybrid kinematic manipulator, which has a patented elbow, which enables keeping the tool orientation constant during the entire workspace, despite having only 4 or maybe 5 degrees of freedom, not 6. And in that way, being very fast and scalable. So that we have, and also upcoming are finally robot language. We released it this July at JuliaCon. And I could give another podcast about robot languages, because it took us 5-6 years, around 7-8 persons here, to develop it together with the customer. Launched this July. So you remember I mentioned that the reason I went from mechanics and control to the computer science department in 1997 was that I realized a good robot language is needed. But it wasn't until summer 2024 we had it and we could release it.
Almost 30 years later.
Yes.
What I really like here is, again, some lessons to be learned, right? You're very in twice now you mentioned customers. So you said that very early on, so you were, working together with a customer on an application, right?
Yes.
And so this is even when you were bootstrapping, right? So this is something that is, I think, for all the deep tech founders here, a lesson to be learned. Get in contact with customer first, and paying out. Trying to get paying customers first, right? Because they tell you the requirements. They know exactly what they want, right? They have an idea what they would like to achieve, not the way how to do it, but what to do, right? And so here you said there was a gap between simulation and reality. So there's another lesson to be learned, that it seems perfect in simulation, but then you go into reality and then you see, there seems to be that not everything that we thought would work out. With better computers and everything, things might change in the future, right? Closing the gap between simulation and reality. But so this was one thing, the getting customer first, but also pivoting So having the guts to say, I tried, but it didn't work out, so I can continue trying, but or can be clever enough to say, there's not too many, there's not too much sense in further trying. There needs to be a good reason, obviously, but always having the guts to pivot and said, okay, I'm not continue going this way. I think it's much clever now to get some investors involved. So yeah, thanks for sharing those.
Yeah. But then one should know about customer requirements and customer finance projects, that it's not to always get full funding, because first there is the confirmation aspect, that if they pay something, it confirms that it's a real need. But typically the problem, at least if you want to solve the problem in a way that's scalable for your own business, you need to do more work than that customer expects or understands that it's needed. So it's normally not fully financed. And that's why you also need the investor money. But now in the end, when we
if you're able to charge higher prices. So this is something that the majority of companies and deals are not able to do, because there's a little bit more involved, and especially tech founders like this, unfortunately. But there's marketing and sales involved, right? So there is a way to raise more money, or to request more money than the customer is typically used to, because he says, this is a robot arm I pay at KUKA, this is a robot arm I pay at KUKA. So when I'm buying a robot from you, this is the range I am comparing you guys to. And so this is the money I expect you. So this is the business I'm in, is how can I charge more for the things that it seems like it's the same, but it's not the same? Is there better service that I'm offering? Is there some unique selling points? What can I actually do to charge more? Because then I'm able to finance the more than just one customer, as you said, being able to scale, to able to abstract. No, this is not the English word, but to not make it not the customized version that the customer needs, but to come up with a framework that works for multiply customers. But please, going back to you.
No, I agree, and it's of course always different technologies, different times. Sorry, I have to. Okay, yeah. So times are different. I mean, 3-4 years ago, it was much easier to find investors, for instance, than right now. Right now, it's an interesting period we have entered, where there is another type of hype around robotics, and the topic of humanoids have become popular. And as a roboticist, of course, humanoids have always been the goal. The question is, how do you get there? And of course, if you have lots of money, you might, in principle, be able to develop fantastic things. But I think if you have all that money you would wish for, you wouldn't reach the goal, because your ambitions get bigger in a way that in an organization, there is not enough focus on the core problems. I know you are at Neura, you have created really good machine designs. And Boston Dynamics is another example of where people do really good robotic designs and really stick to the core of the problems. But if I look at humanoids now in general, I think there are too many core technologies still missing. And it ranges from how actuation is done, the transmissions, the both materials and principles for the joints, the kinematic structure, but also ranging up to how does a humanoid understand its task, and in a way that the human next to it can adjust in a way that makes sense for humans. I see nothing in the humanoid area that really solves the way the humanoid should be built and instructed and, so to say, co-worked with.
So you're really following the videos that have been released. I mean, we do know that videos are always videos, right? So you can do 300 takes until the video looks good. So, but I mean, they're releasing and there are some humanoids already walking around, right? We have very few really in production.
Hmm?
But so you had not been impressed by the videos that you see by all the companies, right?
No.
Nice, good to hear. I mean, it's interesting to see. I mean, you have a lot of experience, right? So one of the reasons why we have such a big portfolio, because we do think that there's a lot of learning that you can gather data-wise from an AGV or AMR, from robot arms, right, and service robots, and then finally at the peak of it, like there might be a future where we have a fully working humanoid robot that all the done or the intermediate steps, as you were calling them, are necessary because there's no shortcuts that you can go and you can do.
Yes, and what I see is not sufficiently high performance. That's one thing, and the other is that it's too scripted. And I sometimes think about that, like the difference between the Russian and Ukrainian armies. The Russians were considered to be so strong and powerful, but all their exercises were scripted. So when it encounters reality, it doesn't work. It has to be non-scripted types of control where there is knowledge and decision making on all levels. And that could range from high level decisions being symbolically transformed down to low level control. Maybe there is a wrist joint that should vibrate a little bit to facilitate that manipulation motion. And I see none of this in the existing humanoid approaches. So now when in this September, we actually got our final piece of work working really nicely, which is about trajectory generation for resonant arms and legs. And so now, finally, after 11 years of work, we have all the pieces well functioning. But I just learned that investors, they don't understand that these enablers has a great value both in automation and humanoids and others. So that's where I am right now.
And now the question comes into place, as I was mentioning before, uh, and this is a mantra we're speaking here at all. Everyone is in sales, so if you are not able, I mean, you can always put it on the other person, like you are not able to understand the implications, the fundamental importance of this topic, right? As you said, it's an enabler for other topics, but then you might need to become better at sales and marketing because then you need to sell the idea to the investors better, so they understand the actually value of that, right? Because in the very end, you would like to invest your money into companies that has the highest probability of being a success. And if you said, for example, there's a lot of companies that are doing good work, but they are not focusing on the essential work that really makes the goal that I have in mind really a reality, then there's a lot of money that you can burn in the wrong directions, right? We just talked about this. So
Yes, but it's actually just 2 weeks since we got our things working. And now I am changing into sales. Because that's the need right now. Yes, exactly like you said.
there's a need. I go into it. I really
Yeah.
love your energy, and I really love that you are so problem focused, right? Or center making the problem the center of the activities, right? Because if
Yeah.
you're focusing only on the problems, then there is no other and if you're sticking long enough and
Mm.
know when to pivot, there's almost no way that you cannot come out as a success. You do need to have the perseverance to stick with
Mm.
it long enough and actually the money to do it long enough.
Yeah.
But yeah, I really love the uh, that this is a motto that is going through your entire your life, right? And there's no finished date yet because
No.
you now entered the next level. Now I need to get the funding for this way. I love it.
Yeah. Now I removed the blurring of the background because I see here
Yes.
in the background I have the Juliet and Romeo, which we released in July. So it's the motion part with motion algorithms, resonance, that's one thing, and the other is this language and runtime, real-time language and runtime. Building on julialang.org. It has the core properties of a language for robotics. I mean, Python and C and C# and Java and all this. It's wrong, fundamentally wrong for reasons I could talk about another time. Julia has done the right approach, but it's not real time. And what we created with several years of work is a real-time version, which is such that the virtual machine accepts also any other languages with that type of bytecode, because coexistence with legacy technology is key. I mean, in automation, there is so much know-how in all the applications and libraries and solutions out there. And that's expressed in one of these 200 existing robot languages. So, of course, we have to support that, but we can bring it over to a new real-time platform where you additionally get our new robot language, Juliet. So that's where we are now.
I am very curious. Actually, after this episode, let's get in contact afterwards. If we really just make a because this is not a technical podcast, right? As I told you before, this is a business podcast. But as this is something, at least from your perspective, very fundamental for the entire industry, so to speak. If this is what you're implicating, right? Let's maybe we do deep dive into that topic. I might need someone else with the expertise to talk about it, because I think this is something I can only listen. But yeah, I'm very happy that you took the time and really went through the entire of your journey and took us with you. I was I'm very interested in those stories, and I hope that the listeners are as much interested as I am. And I'm happy that you shared so many insights and gave away so many behind the scene looks, because this is what those stories are making it unique, right?
Yeah. Thank you very much for having me here.
Then, yeah, like I said, let's have a conversation afterwards. And thank you for this episode so far, and talk to you in the future.
Yeah. Okay. Thank you.
Bye bye.
Bye bye.